Hey guys, I didn't see you there. Some of you may be wondering, what am I doing with lemons? Well, you know what they say, sometimes in life just gives you lemons. And you know what you do with lemons, right? You find the pH of the solution, citric acid, duh. No, but today I am going to show you how to find the pH of a solution, and our compound in our solution will be citric acid. If this is a video that you would like to watch, definitely stay tuned and follow along.
Hey guys, if you're at this section of the video, welcome, and I'm so glad that you're deciding to stick around so that we can figure out the pH of this solution. And the problem reads 4 grams of citric acid is added to a 250 milliliter aqueous solution. Find the pH. The Ka of citric acid equals 7.5 times 10 to the negative 4. Now, looking at this problem, we're just probably wondering now, what do we need to do to find the pH? Well, we're going to work together and figure this out. And I'm going to teach you my tips and tricks on how to find the pH and make sure your answer is always right for those tests and quizzes. What I recommend to do first when reading any kind of word problem, especially if it's math involved, is to identify the units and identify the numbers. Highlight those numbers and those units because more likely than not, you will be using those to find your answer. As you can see, I highlighted the 4 grams, the 250 milliliters, and also the Ka value as well. Now we need to think, what can these numbers do to help me find the end result? Well, what I would say to do first, especially when looking at problems that are like this in particular, is to understand what is chemically going on. So we're going to write out our reactants and our products at this time. As you can see, I have reactants on the left side and products on the right side. On the left side, we have citric acid in our aqueous solution, which is just water. And then on our right side, we have the products that occurred, which is H3O plus and H2C6O7. Now, we want to identify which are our acids and which are our bases. What is our conjugate acid? What is our conjugate base? As you can see, I highlighted in this pretty lavender color what the acids are, the bases, the conjugate acid, and conjugate base. Now, I am simply and easily going to help you understand how to know which one is the acid versus base and conjugate acid versus base. Your acid is going to be the compound that will donate the hydrogen, and your base is going to be the one that accepts the hydrogen. Your conjugate acid is going to be the one that accepts the hydrogen. Your conjugate base is going to be the one that lost the hydrogen. Simple, right? Now, what do we do from here? Remember, we need to find the moles, I think. Looking at that problem, it looks like we need to find the moles. Now, what are moles? Okay, not that kind of mole, silly. I know you were thinking it, but not that one. The moles that we are talking about is the moles that scientists use to determine a compound. Now for you, I've already calculated the molecular weight, which this is needed to even calculate the moles. Why? Because moles, if we talk about units, equals grams over the molecular weight. Once we have our molecular weight, we can solve for our moles, as you see here. So we took the 4 grams divided by 187 and gave us our moles. Then we want to solve for the molarity. And to do that, you take your moles over the volume, and there's your molarity. Now, what do we do once we find molarity? Keep in mind that this Citric acid is a weak acid. It is not a strong acid. With strong acid, those easily dissociate in a solution. Right away, they just separate. But with weak acids, they do not completely dissociate. So we need to use an ice table and also Henderson-Hasselbalch's equation. Now I have already written out the ice table for you. And you can see our products on one side and our reactants on the other side. The I stands for initial. On the left-hand side is our reactants, and those are the 0.56 molarity that we found. On the right side will just be 0. C is for change. We have a minus X on the reactant side and 2 plus X on the right side. E is for equilibrium. Simple mathematics, we're going to take that 0.856 molar minus X to get the equilibrium for the left side, and then for the right side, just X squared, which is 2X's. Now, keep in mind, to find the concentration, we need to take the products over the reactants. So looking at this ice table tells us that our products will be X squared over the reactants, which is 0.856 minus X. And this will equal to our Ka. Now we already know our Ka, which was 7.5 times 10 to the negative 4, and that'll equal to X squared over 0.856 minus X. At this point, we have two options to solve this. We can, one, use the quadratic formula, which is a lot more tedious and longer, or we can calculate, as you see how I did here, we can calculate using the rule of 100. And that rule of 100 tells us that if our number is over 100, we can negate that X. And to see if it's over 100, you will take your molarity divided by the Ka, and if that X value is over 100, negate that X, and let's go ahead and just solve for X. And I did check to make sure it's over 100. It is, and I do recommend that you try on your calculator and make sure that you see if it's over 100, and then you just solve for X. And I hope you guys know how to solve for X. I'll briefly remind you in case you don't, but what you would do is you would want to cancel out the 0.856 on the right side to bring it up to the left side. To do that, you will multiply on both sides. And so we'll multiply 7.5 times 10 to the negative 4 times 0.856. And then to get rid of one of those x's, we'll square root both sides, which will leave us with x equals 0.00801. Now, X is our concentration. Now that we have our concentration, we can now use the pH equals negative log and then put that numeric value in to give us our pH answer, which is 2.1. I really hope this video explained how to find the pH of a solution. I really hope it was helpful and that you were able to follow along. If you have any questions, please leave them in the comment section below, or you can email me, either one. And like, comment, subscribe. Let me know what you guys think. Let me know what you guys want to see next. And until next time, stay beautiful and stay smart, smarty pants. Mwah.